What's up, crypto fam? Sorry, I've been watching so many like uh random cryptocurrency videos, and like I literally saw a guy wearing glasses like this unironically. Like, he was like showing me how to do like thousands of like messing around with thousands of dollars wearing sunglasses inside. I'm like, what's going on? Yeah. So the last 2 weeks, I've pretty much just been looking at studying Chinese and getting sucked into a rabbit hole of cryptocurrency stuff. So I think I mentioned this before. I've been buying high and selling low on crypto stuff for like the last like 7 years, which is not the right strategy. But ever since I started getting back into it about 3, 4 months ago, when I started learning about DeFi, and now I'm like, I'm in. I'm in. I've I've started doing tutorials. I've started learning Solidity. I'm in on this. I'm ready. I'm ready to jump on this rocket ship. Um, so I see a Z. How's it going, a Z? Thanks for tuning in. So I've been really getting in on crypto. I've been really looking at Solidity. I've been looking at a lot of that tech. And the more I look into it, the more it reminds me of where JavaScript was like 9 years ago, or 8 or 9 years ago. What I mean by that is I remember like when I first came to the states, I got hired as like a Backbone JS developer, and then within 2 months, the CTO of the startup I was at was like, "JK, everyone, we're gonna use this thing called React that just came out by Facebook, and nobody really knows what the frick is going on. And we're gonna switch from using Require.js to using Browserify. I remember that, and then the next week's like, oh, now we're switching to Webpack. And so, as my point was, like the tooling for JavaScript world about 8 years ago, if y'all were around here, uh, yeah, React has a steep learning curve. I remember looking at React and thinking like, this is stupid. I'm like, this reminds me of PHP. I'm just mixing. It looks like I'm mixing HTML with. It looks like I'm mixing HTML with JavaScript. I'm like, why don't we just use PHP? This makes no sense. So I was a negative Nancy back in the early stages of React, but thank the Lord, the company I happened to work for went all in React, and thank the Lord, React was a good pony for me to bet on, because at that time I was learning React, but I was also learning Mesos. If you guys remember that, Mesos, it was like between Mesos and Kubernetes in like the containers world of which one was going to become more popular, and we bet on Mesos, and yeah, so that's a lot of knowledge that doesn't really matter anymore. But my point is, now that I'm looking into crypto space, it's reminding me a lot of the developer tooling in the JavaScript world 8 years ago. And what I mean by that is things keep changing, like changing a lot, like changing even more than like people were complaining about like framework fatigue like 6, 7 years ago in JavaScript land, and now things are pretty stable. You pretty much, if you bet on Angular or you bet on React, you're going to be fine. There's always going to be jobs, especially in the banking world. Banking world's really got into Angular, but you pick one or the other, you're pretty much set for life. It's JavaScript land's pretty much stabilized. In as I'm doing research in the Solidity cryptocurrency smart contract blockchain space, it's changing all the time. So if you might not have noticed, but the original title of this live stream was Learning Truffle and Solidity Live. And then literally 5 minutes beforehand, I switched to Hardhat. And I'll explain why in a moment, why I switched that last minute. But Blast HKG saying Svelte and Vue is the cool new stuff. I actually used Vue at System 1 for a while. I liked it. It was fine. It reminded me of React, except they changed the names of a bunch of stuff. I'm really like interested in poking around with Svelte because I like how it uses like a compiler and does everything ahead of time. I'm a big fan of that too. But on front end land, I just bet on React. I did it for 7 years. I'm like, that's there. So now I'm trying to poke around and learn more on the blockchain side, and I'm learning a bunch of cool stuff. So today I kind of want to go over some like learning as I go. So don't take this as like an expert showing you something. Take this more of like your buddy James going over this Hardhat tutorial and poking around and seeing what comes of it, and together we can maybe come up with some stuff. As he says, my first React project was a hackathon project we did together. Yeah, I remember that. Me and Z, when we worked together at System 1, made a browser extension, and we used Gatsby. Yeah, Gatsby and React. And again, I'm a big fan of Gatsby too. I'm a big fan of Gatsby because it removes the need of a server. And so anytime I can avoid a server, I'm stoked. Anytime I can just do everything static, I'm really happy about that. But that's probably because I spent so much time in front end land. So let's poke around with this. So I'm gonna go over why I'm looking at Hardhat over Truffle, and explain some of the differences. And again, a lot of this is literally I'm learning as I go live. So I'll explain my how I kind of figure out which framework to look at. So if I switch to screen share mode, here we go. Okay, so anytime I look at any technology, and I use this trick in JavaScript land a lot, and so this is a great trick. There's lots of lots of different frameworks pop up with fancy documentation. Early on in JavaScript documentation land, and especially now, I'm seeing the same pattern in like blockchain stuff. A lot of the documentation is lies because the technology changes so quick that the docs are almost always slightly out of date. And like I was going through some of the Chainlink documentation stuff about a week ago, and it's the same thing. You click on a link, and it's like, oh, go here to get some Ethereum test stuff, blah blah, and the link's just 404s. So what I learned when I was like really deep into front-end JavaScript land, especially about 6-7 years ago, is instead of counting on documentation, I go right to the source code for popular projects, and then I see what they're doing. And so the two projects I'm kind of digging up in this example are Uniswap, the Uniswap core, and the SushiSwap core. And don't quote me on this. I believe SushiSwap was a fork from Uniswap. And for those who aren't familiar about what the flip SushiSwap or Uniswap are, these are decentralized exchanges. So imagine Coinbase, but instead of having a central ledger and keeping your coins on a wallet that they control, you can actually exchange like from Ethereum to Bitcoin, or exchange from like some random ERC20 token with something else. You can do all this exchanges decentralized. So that's pretty rad. It's like kind of a new way of running exchange. So what I'll do is, here's how I determined 15 minutes ago to look at Hardhat instead of Truffle. So both of these are kind of like frameworks for making smart contracts, to my knowledge. And the reason why I want to poke around with Hardhat is I looked at Uniswap, I looked at SushiSwap, which are both projects I respect, and I saw that they were using Hardhat. like it was that simple. So what I like to do is I'll look at projects. I'll look at either their package JSON file, or if they're using some sort of package manager. If it's a Ruby project, I'll look at their gem file. If it's a Python file, I'll look at their pip requirements.txt file, and just kind of poke around and see what they're using. And so I see here in like dev dependencies, they're using Hardhat. I'm like, okay. They're using some something to do with Hardhat and Etherscan, something to do with Hardhat and Waffle. I actually don't know what Waffle is. Etherscan is like a web interface for the Ethereum blockchain. I know that. I see Chai and Mocha. These are test library types. Decimal.js, I assume that's a math library. Ethereum Waffle. What is Waffle? Let's try Googling this now. And Waffle Ethereum. And literally any package I haven't seen before, I Google. And it's like, okay, what's Waffle? Sweet tool for smart contract testing. Okay. So this looks like it's kind of like Jest for smart contracts. So it's simpler, fewer dependencies. Okay. Nicer syntax, faster. Sure, sounds good to me. And now, is this in JavaScript? Okay, works with Ethernet, works with Hardhat. Expect token to emit. Okay, this looks like it's JavaScript, which is cool. I know JavaScript. I'll bet on JavaScript for sure. So example code. So here's a smart contract in Solidity. And then the test is written in JavaScript. Okay, cool. Okay, so it looks like Waffle's a test library. Ethereum Waffle. Ethers. What is this? Ethers NPM. The Ethers project, a complete Ethereum wallet implementation and utilities in JavaScript and TypeScript. Okay. Import and export JSON wallets. So what? Save Ethers. Okay. So what is this? A complete Ethereum wallet implementation utilities in JavaScript. So keep your private keys in safe sound. Import and export JSON wallets. Import mnemonic phrases. Okay. Connected Ethereum nodes open JSON RPC. Okay, it looks like it's okay, Ethereum wallet implement in JavaScript. Okay, cool. I'm wondering what they're using that for. I'm not 100% sure. Hardhat is what they're using is like a framework for writing the smart contracts. Mocha is testing. This was another interesting thing too. I've noticed that it seems like just from looking at a couple of these open source projects, and SushiSwap is using this too. It seems like they're using Prettier, which is a JavaScript package that auto formats your code. What surprised me is there's a Solidity plugin for Prettier. So what you're able to do is use Prettier to like auto format Solidity code. So that was kind of interesting to see there too. That it seems like the blockchain development communities like kind of settled on Prettier for formatting. So that's neat. So I see a lot of crossover between JavaScript community and blockchain community, which makes a lot of sense because pretty much every developer knows JavaScript, at least even a tiny bit of JavaScript. So I can kind of see why. Because at the end of the day, almost every project needs at least one website. So we have TS Node, TypeChain, TypeScript, and TS Node, TypeChain, TypeScript. I also noticed there's a couple of different linting libraries that different popular open source packages we're using too. I've noticed Solhint seems like the most popular one for me poking around. So I'd probably lean towards using that too. And again, the idea being is if these very popular open source projects are using these libraries, worst case scenario, if I learn the library, then I can at least contribute to an open source project. So it's all about trying to figure out which pony to bet on for technologies and then jumping on, committing, and taking a look. So I have the Hardhat tutorial opened here. I've already installed a lot of the packages ahead of time. So I've installed like the Solidity compiler. I already have Node.js installed. That's just being an engineer in general. I always have a bunch of developer tooling installed. So let's kind of go through this Hardhat project tutorial. So We'll install Hardhat using the npm CLI node package manager. Is package manager okay? So make dir Hardhat tutorial cd Hardhat tutorial npm init yes, and then npm install safe dev Hardhat. Okay, so let's see what we got here. So I've already made a folder here. Npm init. So dash yes. Is that what they're doing? Npm init dash yes. Npm install Hardhat. So let's see here. Clear list. Okay, so npm init made a little package JSON. Npm install save dev Hardhat. Let's see what we got here. Check in installable status. Looks like it's downloading a bunch of stuff. Streaming and downloading at the same time might be a bit slow, but here we go. Let's see what other info we can get about this. Ethereum development environment for professionals. These two people look pretty professional. So it looks like with this we can run Solidity locally and we can do debugging with stack traces. Okay. Tools. Different companies using it. So let's see here. Let's see if it's installed. Okay, so now we have this installed. Okay, we have Hardhat here. Oh, installing Hardhat will install some Ethereum JavaScript packages, so be patient. Okay, that explains how it was a bit slow. npx Hardhat. Create a basic sample project, create an advanced sample project, create an empty config. Okay, so it looks like this tutorial is going through the empty config route. Let's go here. Okay. Type import Hardhat user config. Okay, this is cool. Looks like it's leveraging some TypeScript inside JavaScript. Probably assuming that you're using VS Code. When Hardhat is rendered, searches for the closest hardhat config.js file, starting from the current working directory. The file normally lives in the root of your project. An empty Hardhat config is enough for Hardhat to work. The entirety of your setup is contained in this file. Okay. So Hardhat is designed around the concept of tasks and plugins. The bulk of Hardhat's functionality comes from the plugins, which as a developer, you're free to choose the ones you want. Hopefully there isn't too much choice. I don't want too much choice. I want them to pick everything for me. But okay, let's see. Let's play ball. It's good enough for SushiSwap. It's good enough for me. Tasks. Every time you're running Hardhat from the CLI, you're running a task. npx Hardhat compile is running the compile task. See the current available tasks in your project. Run npx Hardhat. Feel free to explore any task by running Hardhat help. You can create your own tasks. Okay. So that's neat. Hardhat is unopinionated in terms of what tools you end up using, but does come with some built-in defaults. There we go. All about the built-in defaults. All of which can be overridden. Most of the time, the way to use a given tool is by consuming a plugin that integrates into Hardhat. Okay. For this tutorial, we're going to use Ethers.js and Waffle plugins. Okay, Waffle is that testing library I think we saw. They'll allow you to interact with Ethereum and test your contracts. We'll explain how they're used later on. To install them in your project, run this command. Okay. Chai has chai as well. What we got here? Clear. So let's see what we got here. So we got Chai, Ethereum Waffle, Hardhat Waffle. Those seem like testing libraries. Ethers was that JavaScript implementation, the Ethereum wallet thing. Add the highlighted line to your Hardhat config so it looks like this. Okay. Looks like we need to add this require here. This isn't going to work right away because it's still installing the package, but that's okay. Save. Seeing a bunch of deprecated signs. That's when you know you're on the cutting edge. Reminds me of like when React Native first came out, and NPM didn't even have a good package lock system at the time. So you kind of had to use Yarn. It was like super early version of Yarn too. But now NPM's caught up to Yarn on that side, so it's I just right now I just use NPM because actually the main reason I use NPM now instead of Yarn is Yarn made a new version called Yarn 2, and it's just like completely different than Yarn 1. And so like migrating from Yarn 1 to Yarn 2 was very, very, very non-trivial on any like significant project. And by significant project, I mean I tried poking around migrating to it at system 1, and we only had like maybe 10-15 internal packages, but it was, yeah, it was changed enough that the couple of key features I needed in Yarn 1 to make everything run smoothly didn't exist in Yarn 2. But yeah, little story about package managers. I'm very passionate about package managers. I know a lot about them. Okay, so it looks like we installed a bunch of stuff. We're only requiring Hardhat Waffle here because it depends on Hardhat Ethers, so adding both isn't necessary. Sure, I'll play ball. Writing and compiling smart contracts. Let's take a look-see doodle at this here. So we're going to create a simple smart contract that implements a token that can be transferred. Okay, cool, making our own token. One step closer to making an ICO. So token contracts are most frequently used to exchange or store value. We won't go into depth into the Solidity code of a contract in this tutorial, but there's some logic implemented you should know. So there's a fixed total supply of tokens that can't be changed. Okay. The entire supply is assigned to the address that deploys the contract. Anyone can receive tokens. Anyone with at least one token can transfer tokens. The token is non-divisible. You can transfer 1, 2, or 3, but not 2.5. Okay, tip. You might have heard about ERC20, which token standard. Tokens such as DAI, USDC, and Maker, and ZRX. What was ZRX again? Zero chain, maybe? Follow the ERC20 standard. Allows them to be compatible with any software that can deal with the ERC20 tokens. Okay, so simplicity's sake, the token we're going to build is not ERC20. So actually, I took a look. I took a look at the ERC20 standard yesterday. It's actually not too complicated at all. It sounds really complicated. Anything with numbers in their name sounds complicated. But poking around at ERC20, it's basically, it's just, if you remember like object-oriented programming 101, it defines basically a class where you overload some, for all intents and purposes, some methods on the class, and boom, you have an ERC20 standard token. I can see, I guess they're just going to show us to do like the basic version of a token, but I think in the next live stream, depending how far I get in this tutorial, I'll modify it to make it ERC20 standard, because it didn't seem too crazy to make an ERC20 standard token. So start by creating a new directory called contracts and create a file inside directly called token.sol. Okay, so this is one thing I've noticed that's different between Hardhat and Truffle already, is Truffle automatically makes those folders for you, which is fine. So we have contracts, touch token.sol. So I've already installed the Solidity VS Code plugin. Highly recommend it. If you just go to extensions, just type Solidity. It's right there. And it gives you all the syntax highlighting, which is super handy. Paste the code in the file and take a minute to read the code. It's simple and full of comments explaining the basics of Solidity. Tip: to get syntax highlighting, use it to add, same thing I just said. So let's see here. Let's take a look at some Solidity code. So something I like to do while going through the tutorials is I like to set up the linters too. Now, I kind of wonder why people, I guess I can kind of see like people who write these tutorials, they're like, oh, let's just get them up and running, get started. I can see that. But the nice thing about learning what linters people are using is you basically, it's like you have someone on your shoulder tapping you to do the right thing. It's like having a computer yell at you to do the right thing. So I'm going to kind of poke away from this tutorial for a second and install some of the linters. So I found that Sushi Swap is using Solhint. Yeah, Solhint. So let's just install this. Looks like they're using Hardhat Solhint. So let's do, so dv for the tutorial, npm install, save dev, Hardhat Solhint. And what else are they using? They're Prettier. Are they using Hardhat Prettier? Okay, no, they're using Prettier and Prettier plugin Solidity. So let's install both of these. npm install, save dev, Prettier plugin Solidity, Prettier. What other things do they have? Lint, their lint command is using Solhint. And again, I'll copy people's lint commands and then modify them for my own use too. But putting in like a little bit, if I had $1 every time I joined a company or a project, that if they would have just spent the 10 minutes turning on strict mode for a linter at the beginning of the project to save them on a huge amount of technical debt, well, I'd be making an engineer salary. That's one thing I've learned. Like, setting up these linters at the very, 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 very beginning is just so much easier, because then you're fixing the lints as you go instead of ending up with 100,000 lines of code that are like that just aren't working. Prettier right contracts. Okay, so this is Prettier is applying to test files here too. We don't really need that. Just npm run. Solhint-c. Okay. Now, what's their solhint.json look like? Okay. Since default, that sounds good to me. Let's see, is this running? Okay, so yeah, we're getting one lint here. Looks like just need a comment with the license, not a big deal. I'll mess around, fix that later. Okay, so back to this tutorial. So we go here. Actually, let's take a look at the code. So pragma solidity 0.7.0. This looks like it's saying use a version of this smart contract is for versions of solidity that match this contract token. So right now you're witnessing me learning solidity as I go. So this contract token, this seems like similar to how you make a class in another language, I'm guessing, except it's called a contract, which makes sense. Smart contract. Some string type of variables that identify the token. So public makes readable from outside contract. Okay, yeah, this is like a public variable from a class by looks of it, just like in Java or C#. Public name is my Hardhat token. Public token symbol is MHT, sure. Total supply. So it starts off with 1 million total supply. Okay, okay. This is public. Seems odd that this is public. Does that mean someone could change it? An address type variable is used to store Ethereum accounts. Okay. It's the owner of each token, and then mapping. Okay, mapping. This looks like the equivalent of doing like one of these in JavaScript land. So it looks like a key value variable. So it's mapping. The keys are the addresses. Okay. Maps to uint 256. So 256-bit integer. Okay. Contract. Constructor is executed only once when the contract is created. Okay, it's very similar to a class. Balances. Where's message coming from? Total supply is assigned to transaction sender, which is the account that is deploying the contract. I'm not sure how variable scope works in Solidity. Coming from JavaScript land, it's kind of, this looks odd to me. I don't know where the message is coming from. Cool. Where's total supply? Total supply is coming from here. That makes sense. So total supply is assigned to the transaction sender, which is the account that is deploying the contract. Okay, sure. So I guess message is like a global variable. And set the original owner to there. Okay. Function to transfer tokens. The external modifier makes a function only callable from outside the contract. Okay. So that means you can only call this from outside the contract. You can't call this from inside. Okay, sure. I can play ball. Check if the transaction sender has enough tokens. If requires first argument evaluates to false, then the transaction will revert. Okay, so this is like a cert in JavaScript. So require that balances message sender greater than or equal to amount. Otherwise, the error is not enough tokens. Okay, so I remember looking at this yesterday. Require takes in the last parameter in require looks like this is like the error message that gets thrown. Transfer the amount. Okay, just minus the amount. Where's 2? Where are we defining 2? Okay, 2 is defined here. So looks like 2 is a variable that's type address. Amount is a variable type u and 256. Guessing that's a 256 unsigned integer. That's the nice thing about having experience as a developer is they come out with new programming languages and they rename stuff. But once you've been doing this for a while, you can kind of guess. Like, I will bet a freaking month's salary without even looking this up that this is an unsigned integer that's 256 bits. Like I'll bet that just from pattern recognition, doing this for like 10 years. Then read-only function to retrieve the token balance of a given account. The view modifier indicates that it doesn't modify the contract state, which allows us to call it without executing a transaction. Okay. Cool. The view modifier indicates it doesn't modify the contract state. Oh, okay, okay. This is cool. This is cool. The reason why I'm guessing this is important because it looks like if we set something with the view modifier, we don't have to execute a transaction. And the reason I'm guessing why that's important is every time you execute a transaction on Ethereum, you have to pay a gas fee. That costs money, and right now it costs like real money. Luckily, I'm based in Taiwan, so usually when I'm playing around, I'm just trying to click here. Usually when I'm playing around with Ethereum stuff, my gas fees are a little bit cheaper because I'm doing transactions at like 2 o'clock in the morning New York time, so the network's a little bit less busy. But this is cool. This is cool. This is a cool learning bit. If I have something viewable, it doesn't take a transaction. That's good. Okay. The view modifier indicates it doesn't modify it here. So this is just returning the balance of the account. Okay. I can play ball. Not too bad. So it looks like contract is kind of like a class, and each function is kind of like a method on a class. That's what I'm guessing as I go along. Cool. So let's see what the next part of this is. Click over here. Token. So that's the code. Tip. Solidity used for Solidity files. We recommend matching the file name to the contract contains. Sure. Compile contracts. To compile contract, run npx hardhat compile on your terminal. Okay, makes sense as a built-in task. Let's see if this works. Clear. Anonymous crash reports? No. It's my data. Downloading compiler 0.7. Let's add the license here so it doesn't complain. Let's just do MIT. Y'all can copy this code. Make your own tokens, that's fine. Compiling successful. Let me just make a Git repo. I kind of wish that Hardhat would create a git ignore for you by default. But sure, whatever. Artifacts, cache, and contracts. I'm guessing those are supposed to be ignored. Let me Google Hardhat git ignore. I'm going to copy theirs. Copy. Pasta. Oh wait, are they using JSPM on their project? People are still using that? I remember we used to use JSPM at NFL. Why are they using JSPM? No way. No, I don't think so. Let's see. JSPM. JSPM packages. Oh man. I didn't even know JSPM was still around. We were really using JSPM at NFL. JSPM. Okay, one sec. Going off a tangent. Oh. 2021. Huh. I wonder why they're using JSPM. Okay. Well, that's that's why it's easy to get a little bit distracted. Git add. Do I need artifacts? I'm going to add artifacts to the git ignore. I'm going to add cache to the git ignore. Okay, everything else looks legit. Just doing basic stuff. Okay. Just don't want to lose my place. Okay. Contract compiles ready to be used. Testing contracts. So we have about 15 minutes left. Writing automated tests when building smart contract is of crucial importance, as your users' money is what's at stake. That's, again, one of the really crazy parts about this is like just how much money's in this. Like when you make a website, it doesn't even have to work. Like if a website works 95% of the time, that's 10 out of 10. But for here, like there's like a lot of real money going through these, so it makes sense that they're talking about testing. Use Hardhat network, a local Ethereum network designed for development that's built in the default network for Hardhat. You don't need to set anything up to use it. Cool. In our test, we use EtherJS interact with Ethereum contract we built the previous section and Mocha as test runner. Okay. Create a new directory called tests inside our project and a new file called token.js. I wonder if you could use TypeScript, but I'm not going to mess around with that right now. It's lowercase t. Doing with an uppercase t. Let's start with hello. We'll explain next. For now, paste this in token.js. Okay, let's see what this looks like. Okay, deployment should assign the total supply of tokens to the owner. Async function. Wonder why they're not using arrow functions here. Maybe just out of date. It's kind of weird. Okay. Ethers get signers. Get the owner. Get contract factory from token. Token's the name of our contract. Deploy it. Hardhat token balance of. Okay, that's neat. npx hardhat test. Okay, so to go through a little testing thing here. Clear, paste. So it looks like. Okay, cool. Ran a little bit slow, but not too bad. Test. Now let's explain each line. Okay, we can go through each line explaining here. Let me click over here. Const owner equals await ethers get signers. Okay. I'm guessing the owner is from the get signers. A signer in ethers.js is an object that represents an Ethereum account. It's used to send transactions to contracts and other accounts. Here we're getting a list of accounts and the node we're connected to, which is, in this case, is the Hardhat network. Okay. And only keeping the first one. Okay. I guess there's only one. The smart contract we wrote only has one user by default, I'm guessing. The ethers variable is available in the global scope. If you like your code always being explicit, you can add this at the top. I like my code always being explicit. I like being explicit. I like writing down everything. To learn more about Signer, you can look at the Signer documentation. I'm going to open this in the tab in the background, so I remind myself to look at this later. Const token equals await ethers. A contract factory in ethers.js is an abstraction used to deploy new smart contracts. So token here is a factory for instances of our token contract. Okay, sure. Factory. I remember factories. It's like reminding me of learning Java and C Sharp back in college with factories. Of the last couple of years, I've been like all in functional programming. So it's like it's so funny. Like the thing that like I started from like 7 8 years ago. It's coming up again. It's just it always goes in loops. Once you learn, like once you've worked in this industry as an engineer for like 3 years, you realize every 3 or 4 years they rename everything, but it's still the same stuff. So that's good to know. Deploying a contract factory will start deployment and return promise that resolves the contract. Okay. Subject as a method for each of your smart contract functions. Cool. Once the contract is deployed, we can call our contract methods on Hardhat token and use them to get balances. So I'm wondering, is this Hardhat network running locally, or do we have to be connected to the internet somehow? I think it's running locally. Remember that the owner of the token who gets the entire supply is the account that makes the deployment. And when using the Hardhat Ethers plugin, contract factory and contract instances are connected to the first signer by default. This means that an account in the owner variable execute the deployment and balance of should return the entire supply amount. Okay, that makes sense. So that is, they're talking about here. So when the contract's deployed, all the supply is being sent to the owner. Okay, so that's what we're testing. This is using shy. Shy is the assertions library. These assertion functions are called matchers, and the ones we're using here actually come from Waffle, which is why you're using Hardhat Waffle plugin. It makes it easier to assert values from Ethereum. Check out this section in Waffle's documentation for lists of Ethereum-specific matchers. So the other interesting thing here is this is all like Ethereum blockchain stuff, but if you're looking at Solana or Cardano, it's completely different. Like Solana is all using Rust and C. Cardano is using like Haskell. So this is why it's gonna. I think Jeff Atwood put it best. He has a quote that says, "What's Atwood's law? What's it, Jeff Atwood's law?" This guy, one of the guys made Stack Overflow. Atwood's law. Here we go. Yeah, any application that can be written in JavaScript will eventually be written in JavaScript. So I'm leaning towards JavaScript land. That is so true. I bet my entire career on JavaScript years and years ago, and time again, eventually, everything will eventually get rewritten in JavaScript. That's why I'm a lot more bullish on projects like this and more bearish on projects like Cardano. Not because I don't like functional programming. I love functional programming. It's up to me. Like, I actually prefer using something like Elm or Haskell over JavaScript any day. But it's not up to me. It's up to the rest of the world. And the rest of the world will eventually go into JavaScript. So that's why I always lean on JavaScript. For doing anything where like I actually have to get work done, I'll always do JavaScript. And for anything hobby related, I always like using functional programming whenever possible. But I never, besides using like functional style React, I've never had the chance of working on like a production app in a language like Elm or Haskell. I'm definitely open for it though. It sounds fun. But we see. So using a different account. If you need to send transaction from an account or signer in either JS speak, other than the default one to test your code, you can use the connect method in Ether.js. Contract to connect to a different account like this to transfer tokens between accounts. So this deployment, so it looks like I can just put this in the same test file. What's this do? It should transfer tokens between accounts, so it's not even using owner. What I like to do is if I'm not going to use the variable, I do underscore to show. So we're destructuring the array, and the functional like Haskell way to do it is like when you're destructuring, you're not going to use the variable, you just underscore. Style choice. It's okay to use owner. So get signers should transfer tokens between accounts. So get address 1, get address 2, token, get contract factory token. Okay, so same thing as here. Hardhat token. Okay, so this gets token, this deploys it. Transfer tip 50 owners from owner to address 1. Transfer address 1 dot address 50. Okay, so this has a reference to the owner. So expect this to be 50. Connect to address 1. Transfer to address 2. Expect equal 50. So let's try running this. Okay, cool. Okay. Okay. Getting there. We're learning. Full coverage. Now that we've covered the basics you'll need for testing your contracts, here's a full suite for the token with additional information about Mocha and how to structure tests. We recommend reading through. The documentation's pretty good. You can tell though it definitely is missing the polish of some of the docs in like the React community and TypeScript community, but that's okay because we're just starting. Like they're just starting. I'm not throwing shade. I'm not throwing shade. This is great. This is much better than where things were 9 months ago. But it'd be really great if they had one of those like editors, like where you type, and you run the command. What's that word again? Like you know, when you type the command, I feel so silly. When you type the command, and it's not a CLI. It's like you type on the CLI and it returns right away. I forget what the word is. It feels so silly. But at least they're putting a lot of comments on the code here. So should update after transfer, should fail. Save deployment. Okay, let's try copying all this and reading through. Okay, import chai. Cool. So we can use expect. Describe is a Mocha function that allows you to organize your tests. It's not actually needed, but having your tests organized makes debugging them easier. Yes, I agree. All Mocha functions are available in the global scope. Describe receives the name of a section in your test suite and a callback. Again, I don't know why they're using these instead of arrow functions. Mocha has 4 functions that let you hook in before each, after each. They're very useful. Common patterns, declare some variables, find them in the perform before each callback. Okay. Setting these global variables, that's okay. I'm okay with global variables for tests, generally. You can get into some weird state issues using global variables for tests, but it's fine, generally. Actually, you know what? I'm a big fan for tests. It's just, I don't like using before or before each. Just every single test, I just make all the variables again. And yeah, that means I'm pasting some code around a bit. Honestly, I found that pasting the code around makes the test way more easier to read in general. And like the kind of dry principle, which makes a lot of sense most of the time in the actual application code, doesn't really matter for tests, because generally, like when you update some code, you want to fix the one test, and sometimes you're changing the functionality entirely, and so you have to change the test entirely. But it's fine, it's just a style thing. Token owner. So there's owner, address 1, address 2, and all the other addresses. Okay, that's neat. So I guess that'll turn into an array. Declare contract, which is called token deploy, and wait for it to have been deployed. Okay. Okay, so I'm gonna read through that a bit later. Let's try running this because I'm running low on time. Only have about 5 minutes. Okay, those are passing. I'll read through that a bit later. So let's wrap things up for the day. So that was office hours. There we go. Okay, so that was going through initial Hardhat Ethereum stuff. Again, that was the first time I looked at this, but just by looking at it, it's not as scary as I thought. Solidity doesn't look too like, obviously there's like the intro, so there's not going to be anything too crazy complicated. But I'm really happy that a lot of this stuff in this blockchain ecosystem is leveraging stuff from JavaScript land, because like I said, I spent a ton of time learning JavaScript, so it's nice to see a lot of the tools that I'm already familiar with, like Prettier and ESLint, being used over here, which is great because it means I'm building on top of knowledge I already have. All in all, I'm going to spend the rest of the week really digging into more Ethereum, more like blockchain related stuff. And again, I stream every week. Next week, expect like a much bigger deep dive on this. I'll report back on everything I found and try to package it up. But all in all, I'm really excited about this. I haven't been excited about like a tech thing on programming space in a long time. So I can see why a lot of other like tech people, like a lot of my buddies out in California, are like starting to jump in on the blockchain side and get into the coding side, because I can see what this really is reminding me of like 8 years ago when React was coming out and when Angular 2 was coming out. So if you're even remotely curious about this stuff, I highly recommend continue to look into this. A lot of these blockchain companies are getting massive amounts of money from investors, and they're reinvesting that in the community through like hackathons. So a good example is like the Solana hackathon. Like, I think like 2 or 3 projects from the freaking hackathon got funding from VCs, got like $2 million in funding from VCs, like 3/4 of the way into the hackathon. Like, there's some crazy moonshot stuff going on here. And so as an engineer, I really recommend you like going back to being curious and taking a look at this stuff. And especially if you've done this for a while, I kind of lost my curiosity a few years ago, and because I got stuck in the day-to-day coding side. So I'm actually pretty excited to get that curiosity back in this space. So that being said, I'm going to drop the link to the Discord. Where are we? Link to the Discord will be here. I'm dropping that in all the chats. So that's jameshutch.com. Link to the Discord, contact. Let me copy this. Copy link. So if you're interested in this stuff, I talk a lot about tech and learning Chinese are the 2 main things I'm focused on. Here's the link right here. Right click, paste. So join the Discord if you want to meet up with other engineers, other people who are interested in this kind of stuff, and talk through. And that being said, thanks for watching. Appreciate it. I will see you next week. I stream every single week at the same time.